Thank you very much for that introduction. So, as he also said, we're going to be talking about tri-state locking, reducing locking in the runtime, and we'll talk about that, what that means. My name is Mads Gram. I've been with Microsoft for about 8 years now. I started as a student worker and then a team, and I had this great mentor called Jorge. You might know him. He was there for a long time. And then I moved to a new team, and this new team was the server runtime team, and I was put right next to this very nice guy, Torben, and he kind of became my new mentor, I would say.
Yeah, thank you very much. I'm Torben with Meyhoff. I was with Microsoft from 2005, starting on the first server back in the days. And then I worked until 2019, way through our multi-tenancy and enabling every old code from the seaside days to be able to run, and worked on most of the features in the server runtime over the years. In 19, I had like a little journey outside of Microsoft to do a similar cloud lift for another company. But 1st of April, back again. And it's good to be back on the scene in TechDays. This is my favorite place to present.
Yeah, and we're also happy to have you back. Just a little bit of a practical kind of question. How many people in here, by raise of hands, were here last year when we did a slightly similar presentation about locking? So, if you're here last year, let's see. Okay, so it's actually not that many. I think I'll go a little bit in depth with some of how it was last year, and then of course go really in depth with how it's going to be in the future, or the future is now actually. And then one more second thing. How many people are planning to stay for the second session? Just by raise of hands. Okay, that's significant. Oh, really nice. Okay, so we have a pretty packed agenda for this first one. We're going to try to make through as much as we can. The read isolation thing, only if time permits, right? We have presented that for, but it's super crucial to understand this. So if time presents or permits, we will also do that. Torben, take it away.
Thank you very much. And I'll start by introducing why do we have logs and what does log means in a business application. Because logs is good, but logs can also be bad. But AL is a single-threaded execution, and it can run on multiple processes. In normal places in code where you want to do concurrency and you want to keep people away, you can do mutexes, semaphores, whatever you want to do to keep people out. But if you want to have them out of each other, cross processes and cross sessions, you need to do something else. And we use the database to do our logs with, to do concurrency control, isolation, also prevent deadlocks, because if two people take different logs in different directions, you easily end up in situations where you will have a deadlock and people in the end, no one can continue and we'll have an exception and we'll die. But logging is good because that's the way we can do consistent data, balances, all these things. But we need to limit the amount of time we do the logs, of course. And especially Mads will drill in, deeper into those part of in the presentation. So how big a problem is it actually? So every day we have a lot of timeouts, log timeouts, 150,000 on 6,400 tenants on a daily basis. And some is really bad, and they have other issues, and most probably they are using the system in a way where they hurt themselves by using APIs or other recurrent jobs. So I think that's a debug situation that is specific for some. But you can see the amount of logs coming from patent extensions is 16. So there's a big place for others, and App Source apps has 3 out of 20 where the logs come from. But that means, the most of the heavy logs comes from the base system because that's where a lot of the complexity goes on. And even though we try to remove them, we have more and more traffic on the machines, more and more users in the cloud, and that increases the log timeout. So it was crucial to get some of the new features that we're talking about through to make sure that we can get logs even smaller in the future. So, just to get you into pace of what you guys know about the logs. So we made a little quiz. I think you introduced it last year, Mads, with Nicola. But let's try some samples out here. So, what does log table do? Does it lock the table?
Oh, that's nice. People know.
It doesn't lock the table. Okay, let's get one step further and then. Okay, what does now we run the log table. It didn't lock the table. What happens then when you run a customer.find set afterwards? We did the log table on the customer table here.
I'm hearing a lot of right answers, so that's nice.
It locks, exactly. All right, now we log on one variable of type customer, but we do a find set on another customer record. It logs. All right, next one. So the actual meaning, actually, if you're looking at it, it's actually an instance variable, but that's something from the past. Log table was made way back in time. It is actually a static function, you know. So put a predicate on a particular table. It's actually for all usages afterwards on that table, where log table is going to be applied.
And my excuse for why we didn't change that name is it's before me. And so now I look at you, was this...
And even 2005 is also before me, so that I have the same excuse. But you know, we're now introducing more things to make it easier for the future also. All right, another example. Read after write. You know, first we have a find first, we take a record out, we modify it, and now we do a find last on a different record. What happens now? Does it log? Indeed, it logs. So as soon as we enter into a write transaction, it will also log on any table usage afterwards also. All right. Another thing then, okay, let's see if we can do some more stuff with analysis. That's often happening in business code is that you also have to do some counts as well also. What happened on the count in the case where we are also in a write transaction right now? Exactly. Now we have range logs. They are even bigger, and you're going to go a little bit more deeper into range logs afterwards also, so we make sure that we can log out more things in the database. All right, this is one a little bit different then also. Now we have a delete all. And now we have a find set afterwards. So we first deleted all the data, and now we do a find set. What happens? Exactly. We log, and the delete all, you know, put a predicate on everything on it. If you had like a empty table and you do a find set, you actually log for all inserts afterwards. So it's not just what you actually selected on or what you used on. You do a log of the table also if they're empty. So you're the only one that can insert afterwards. All right, sample more. We do an insert. Insert fails, but what happens after the insert if it fails? Exactly. So we are in a write transaction again, and logging has appeared. We have to change to write transaction, and that means that we'll be in the log mode. And the last one, flow fields. What happens when you do a calc field on a flow field? Exactly. There's some smart SQL also that doesn't do it, but most, be careful when you do the range logs, and that's why you need to be able to limit your amount of logs that you will have in the system. All right, so we use the database for logging. The behavior of the writes is the SQL default behavior when you do an insert or you do a modify, an update. So that's the default behavior. But we decorate the reads. So we can do read uncommitted, read committed, repeatable read, and update log. So that's our special behavior on top of it. The rest is actually SQL's default behavior on using the database. So let's talk a little bit about what transactions in AL is about. And every time you enter a function, you're actually already in a transactional scope. But talking to the database and arrange a transaction start is actually pretty expensive. So if you only come into a place and you only run code, we don't want to make a transaction. So it's actually a virtual transaction we have in the runtime. But we are ready to promote the transactions for you when you go on. So as soon as you do any of the operations, they will escalate the transaction. I'll come a little bit more into that afterwards. And that transaction will stay, So you can get rid of a transaction by doing a commit or leaving the scope in the end. And your logs will be held for the period that until you commit, because you have to keep everyone else out until you do a transactional commit to the database. So let's look at a little sample here. We enter a function inside AL. First, we run some non-transactional code. SQL doesn't know about us yet. We don't have any transaction started. But now we need to do a read from the database. So the first thing is that we call the database, and please give us a read transaction. And then we do the read afterwards. And we select uncommitted in the beginning, if there's only in the read state. As soon as we need to do any write to the database, we have to promote the transaction to a write, and now we change the behavior. So we do the insert and get on, and we run more code. And then we do a select afterwards on the table. Now all the selects has the update log, at least until we see some of the tri-state log that Mads will talk about afterwards. So some of the changes where you can actually do lighter logs. Then you run more code, we modify the data, and we have the timestamp checks to make sure that you don't have violations and got stale data before you're trying to persist them to the database. When we leave the end transaction is committed, or if you error out, we do a rollback on the transaction, or you can roll back the transaction by doing any error in the code, and then the transaction will be deleted. But be careful sometimes, because we looked at very simple samples here. We have one record in play. We took a scenario here where we used posting of the sales order, and this is just one of the simple ones. You can make it much worse if you have more variety of data inside the sales orders you want to post. But we're touching 25 tables, so there's a big opportunity to actually go in and make logs with others. If you go and log these tables, then you might end up in a situation where you'll not be able to post from other threads. That's why you often synchronize these on job queues and others as well also. But then, there's a lot of tables involved in many of the business operations, and you end up easily being able to make logs if you touch the most used tables. So log table, not quite what it is, what it says, but it is there to help you, ensure your data and your integrity of the things in your database. But let's follow on a bit for you, Mads, and continue into two-state and three-state logging.
Thank you very much. So two-state logging, or kind of didn't have a name back in the days. This was just the default logging for a very long time. I don't actually know when it came, because it was way before me. Torben, do you know?
I think that's the default behavior all the way back to FinExe days. Some of the audience still remember FinExe.
Yeah, so...
the native database.
So probably from back then. And then until version 26, sorry. And right now, you could, and you should maybe, go in and enable it for your tenants, right? We say version 26 because that's when we're going to de-support it. It kind of, if you want to summarize it, it's kind of pessimistic logging for reads within a transaction. We'll discover that a little bit more. And as Tom said, we're applying these logging hints to SQL statements. Only the one for reads, we don't do it for writes. And then they affect the table state of a given table in a current transaction. Now, let me try to set up a rule for you that's very nice and easy, I at least think, to follow. So if we have this there's two states. As you can see, my overwhelming creativity here with the naming. So we kind of start off by easily just saying all reads are done with read uncommitted as long as no writes or log table has been done to the table state in the current transaction. There's an asterisk there, there's a caveat. The caveat is only if you're using the default transaction type. Now I looked in base app and I didn't find any places that didn't use that except tests. So if you're using your code, it's going to be slightly different. I will happily explain it to you, not right here on stage, but you can come after and we'll discuss it. And afterwards, when write has been done, and I say all log table, but a little bit of a internals thing, log table and writes are actually the same. So when we do a write, delete, modify, insert, delete all, modify all, we anyway just call log table for you in two-state logging. So they're actually the same. Just for two-state logging, think of them as the same. But for the remainder of the transaction, any subsequent read will be done with the update log hint against the same table, right? A little bit abstract maybe. Let's take an example, right? So we have some code here, very simple code. I hope, yeah. And let's try to go through it. Assume that no other code has run when we enter this action. So there was no on before action event, nothing like that. Just this is the first thing. cur.find last. What hint are we going to apply here, right? And you can say it if you can kind of guess it. There's only two, so it's 50% chance you get it right. Okay, I heard someone saying it, so yes, read uncommitted, right? So after a delete, this is a write. So we suddenly have to say, okay, we did a write, so it cannot be one. So now you have a 100% chance of getting it right. So I'm not going to ask you, but yeah, it's update log, right? So let's continue down into the new function. We have a new record instance we have a new variable, it feels like everything is different, except it's still the same table. We're still on the currency table. We have done a write and implicitly a log table due to that, and therefore we go with rule 2 and say update log. Okay, cost.find first. We are on another table now, right? So now we go back and go, oh, okay, has there been any write or log table on the customer table? No, so we on read uncommitted. And luckily I wrote the slides here correctly, so that's nice. Now, read uncommitted, read committed, what does that mean? Update logs. Well, let's take a little dive into SQL. And it's gonna be a simplified view, because we could probably do a 90-minute session just on logs in SQL. My manager told me he read a 500-page book on that recently, so maybe not for now. But we'll just cover the basics. So SQL Server, and actually SQL, the language, has this concept of isolation levels. So we start off with the read uncommitted, also how we start off reading. It has no logs. It does not apply any logs. It just allows you to go directly ahead, go crazy, do all the fun things and dangerous things. So let's take an example. So let's say we have me and Torben. We each have our own session. And Torben came first. He also came to Microsoft first, so it's fitting. And he went in, read the data, wrote into it, let's say 42, right? Some nice value. And then I come and read. And I didn't do anything else in the session, so I just get to read uncommitted. I read 42, and I begin doing some decisions based on that. Meanwhile, Torben, he figured out something went wrong, right? Maybe he called random dot something and got a value, and then he bailed out because of that. So he rolls back, and I still read 42, but that never existed in the database. That value was only there in a transaction. So I'm maybe now writing something somewhere in another table with that 42 value, but that never existed. So now you get inconsistent data, and this is called dirty read, and all the conflicts that comes after that. However, no logs were taken, so I was allowed to run really fast. And this is kind of an example of where you actually sometimes do need some logging, because else you can end up with this kind of behavior. So how about update log? Update log does not allow any of this. It's quite strict, actually. There's no dirty reads, because what happens, and if we go back to the other example again, I'm about to read, Torben already wrote, he wrote 42, I come, and I go, okay, I want to read that, but I get blocked, because it's a conflict. So I have to now wait for Torben to read, Torben to commit or roll back. And I either get the new value or the old value, right? Exclusive log is kind of just an even stricter version of update log. We only use that when you write to the database. Now, this is what's called a compatibility matrix. So we can kind of go through on the left and the right, left and the top hand. Think of that as two different sessions. Again, me and Torben session maybe. And we maybe, let's say the one on the left, your right, on their right. And then I'm coming there trying to read with something, and Torben has a log up there of the different types, right? No log, well, there's no log, shared, etc. So let's try to kind of play through a few scenarios. So let's say we did a write, both of us, me and Torben, both did a write. I did it on the first row, Torben did it on the last row. And then we're trying to read in the middle, right? Some random value in the middle we're trying to read. And we are on two-state logging. So Torben reads with update log first. I'm also trying to read with update log. Well, if we look at that one, you look at U update, and you follow along until you find the U update up there. You will see it's a red C. Now, red, it's a bit a matter of perspective. Red can sometimes be shown as negative. But for me, it's negative because I get blocked. I have to wait for Torben. But you could also look at it as positive, right? Because now I'm going to get the right value. It's just about what you want to do. But from a logging standpoint, this can give log timeouts if Torben's transaction is long, right? We could also take the first example, just if we're both reading read uncommitted. Well, no log, it's green, it's an N, no conflict, we both get to run ahead. One more thing. So the one I showed to you was kind of the nice one you have to think about. This is the real one from SQL Server. You can find it on the internet. You can sit and study it. Most of these things we don't have to think about because it's like schema logs and stuff like that, and we don't change the underlying table, so you don't worry about it. But I just wanted to show you reality, which is a bit more complex, unfortunately, or fortunately. So SQL Server has this optimization, which when I tell it to you, I'm not sure you'll think it's an optimization. It depends on how you look at it. SQL Server, normally when we go in Business Central, we operate on a single row at a time most of the time, right? You call modify, that operates on one row. You call get, or you call find, and then you next, right? So we take logs on a row basis most of the time. So one row, like one modifier, one log, right? But SQL Server, due to memory constraints, will, after some amount of rows, go in and say like, hey, wait a second, you're taking a lot of logs, that's costing a lot of memory. Let's just go from having these small granular logs and just escalate it up to the table level. So suddenly you can log an entire table, even though you only read or impacted some amount of rows. And I think Torben told me, how many was it?
5,000.
Yeah, so if you read more than 5,000, and on big tables, you can pretty easily end up reading more than 5,000, especially with stuff like doing counts and stuff like that. But yeah, it saves memory, so I mean, that's nice. So, tri-state logging, and again, you can maybe guess where the name comes from. I don't know. Else you will see it very soon. You'll see the creativity. But before we do that, let's talk about why. So we saw a little bit of an introduction to it from Torben with the crazy amounts of log timeouts that we see based on data telemetry for our side. And I'm sure you're looking at your telemetry and also seeing these kind of things. I'm sure your customers are also telling you these things. So we were kind of looking at it, and I looked at telemetry, and I kind of tried to query around and see what is the type of statements that are leading to logs. Because I think most people would probably think, oh yeah, it's because you're writing something. But around 50% of them actually comes from reading. And if you then go and see, why is that? Well, it's because we're reading with update log. And update log is not self-compatible. So, you kind of easily end up blocking each other. We also kind of found out that we probably in general should just reduce logging, because we keep hearing, and I think also after last year's presentation, there was a bunch of people asking me about it. And the funny thing was that when I did last year's presentation, I was presenting two-state logging. I don't think I called it that back then. I actually had the code for tri-state logging on my laptop somewhere. I couldn't tell you about it back then, but so it's here now, and I hope that's nice. So how can we reduce logging? Well, we were kind of looking at maybe we can just have less log tables. We can just tell people to not use log table. But I feel like people knew that already. I think most people, when they used log table, there was kind of they really wanted to log it. They didn't care about it most time. So, and we looked around in base app code and just other code places. We saw that it's quite frequent that you end up in this scenario where you write and then you do a read later. I'm sure you can nod if you agree here or something like that, but that's a pretty common pattern. And when it comes to event subscribers, you can't know what state your table is in, right? Because they might call log table, they might do a write, and then suddenly your code that you knew didn't do any writes was suddenly doing a write. Secondly, we couldn't really tell people to not do writes anymore. I feel like basic AL code sometimes have to write data, correct me if I'm wrong, but it's pretty necessary. So we came to the conclusion that it had to be done at a runtime level, so the NST, right? We had to go there and make some changes. And this is what we did. So we introduced another state, so tri-state from 3, yeah. And the way you should think about it very easily is just that we took the second state before and split it up into 2. So now there's 3. The first one, exactly the same, no change. If you remember it from last time, it's good. Second one, if writes has been done against the table in the current transaction, further reads will be done with read committed. Right? So this is the difference. We'll come into what read committed means. I think it's on the next slide. And then, if you call log table, and we know you do that, well, maybe not you, but we know base app does that a bunch of places, because it needs to have that behavior. Well, don't worry, it's exactly the same. We didn't want to break you on that one, right? So if you're worried about that, don't be. And the same caveats as before, assuming default transaction type, right? So let's run through it, right? Again, I'll do it a bit quicker this time. So read uncommitted, the first one is the same, there's no different, right? So we don't have to check that one. Okay, delete, we do a delete, that goes to SQL, it writes, takes a xlog, and then we go cur.find first, right? Let's go through them. It's not number one, because we did a delete. Number two, if write has been done, yes, write has been done, but there's no log table call. And in the code, internally, it's no longer writes, delete, modify, insert, no longer called log table, because, that would defeat the point. The name in there is, I think it's transition to write or something like that. Very creative, I named it. So we now do read committed, right? So find cur.find first, read committed. And I wrote it correctly, nice. Okay, so let's continue into the other method, see how it behaves there, right? It's the same. Read committed all the way through, because it still pertains to the table state, not the record state, not the method scope, nothing funny like that. Okay, and next one is on another table state, so it's read uncommitted, right? Okay, log table. I promised you there's no difference from before, so we go to the third state, we say update log, right? Good. So there's one new isolation level I showed you, so let me just explain that one, because it's a little bit different than some of the ones we saw before. Read committed, it does not have this problem of dirty reads or uncommitted reads. And the way it kind of accomplishes this is it places a shared log. You saw those on the compatibility matrix, don't worry, I'll show them again. And this will allow it. So if we take the example again with me and Torben, right? So Torben goes in, he writes to the database, 42 or whatever he writes, and then I'm trying to read that. Well, I go in there, I put a shared log. Shared log is not compatible with xlog, so I will have to wait. I'll have to wait for him to either roll back or commit, and I will either get new or old value depending on that. Update log we already saw, exclusive no we always saw. So if we go here and we try to, this is really interesting. Let's take the example before with Torben. He writes at the end, I write at the end, I write at the start, he writes at the end, and then the middle we try to read, right? So let's try to follow shared and shared. So it's in, right? No conflict. This means where we could not read before at the same time, we can read together. We can both read this one, right? So after write, you're no longer taking these self-incompatible logs blocking out each other. What is even more interesting is here, look at S versus U. Shared versus update is also compatible, which means if somebody comes and logs by using update log, you can still read that. Now, the person who's reading with update log wants to have a consistent view of data. That is generally kind of perceived as what you do with update log. You do not say, I need to you kind of say you need to change that if you want to, but you need at least it to consistent since you read it. But that doesn't mean I can't read it. It just means I can't write to it. So we're also kind of guaranteeing the promise of that, and I can read from it there. Now, of course, when you have someone writing, I will be blocked. So the last kind of really important SQL around thing here. When you're used to kind of log table, and I think Torben talked a little bit about this, the length of logs, and length is like an abstract way to talk about like what's the length of a log. Well, it's transaction based, right? So if you take it at the very start of the transaction, and then you spend a ton of time doing other things, like in this case sleeping, which is probably not the best way to do it, but let's just say you did that, I don't know, 100 seconds or whatever it is, you're now going to be holding that update log for the entire sleep duration, blocking everyone. I mean, no one would write this code, but pretty obvious. However, if we then, in this case, we would read isolation instead of writes, we go in and read committed, and there, when you do the find set, the length of the log is only at the statement level. So when you go in and read, you're going to select something from blah, blah, blah. And then, as soon as you return from SQL, you are now releasing that log, allowing the other people to interact with that row while you're sleeping. I mean, probably you doing something useful, but in this case, sleeping. Now, I hope I convinced everyone that, this is great and you just want to go and have it and you're happy and everything. Well, so the way to enable it, if that is you right now, then tenants created after v23 have it on by default. So, if you're a new tenant and you didn't disable it, it's there right now for you and you're happy and everything. Older tenants, they must opt in via the feature management. From version 25 and on, it will be on by default for all tenants. But you can opt it out. So you can just open the feature management, that's the first thing you do, and disable it. Until version 26. From 26 on, this is the only way we're going to be running. Now, the uptake rate is about 12% in SaaS. I queried telemetry, and I got a kind of approximate number. It might be a few percentage on off. But we have had a lot of large on-prem customers who are now testing it out. You can read about it on the internet. There's some nice people out there blogging about it. I think some of the MVPs. So here's if you're not used to the feature management page, just go here, find enable tri-state locking in AL, I think it's called, and switch it to all users. We recommend that you start off right now and go and have some fun, play with it in sandboxes, run all your great tests, apply your brain power to thinking about your code, and if you have any problems, come talk to me, send me an email or Torben, and we'll probably look at it promptly. So with all that, what does this mean to you? What is the kind of takeaway around that? The first thing is, if you depend on log table, if you explicitly knew, here, I need to have a log, update log after I read, it's the same, no change. Everything's good. But if you don't do that and you're just doing a write and you read afterwards, the log will be held for a shorter amount of time. Reads, well, actually, at least read logs, not write logs, they didn't change. Reads will be more concurrent, right? They're self-compatible. You can read two of them. So therefore, go test. Play around, have fun, because it's being able in 26 for all. So we have some time, so I'm going to go through a little bit of some kind of examples code that shows kind of the power. These are a little bit harder to read. I think you can read them. But the idea is essentially to show the difference between two and tri-state locking, where under two-state locking, this would not work. So if you take the action on your right-hand side, my left-hand side, and you run it, under two-state locking, this would fail, but under tri-state locking, this doesn't fail. And the reason is that these finds are now compatible. Good. I hope that's clear. Now, this is kind of the core change that we made, and this is what you need to think about when you're seeing if you can do this, if you can use this. With transaction length logs, when you're reading with update log, you do not have to worry about anyone altering the data from another session, right? So let's say we do a write on some arbitrary row, and then we do a read committed on another row, right? We only have a snapshot of the data. We don't leave a log on it. So someone else can come and modify that row in between. This was not possible with update log, because then they had to wait. So this means you can get stale data in another way. This is the kind of, this is the thing. This is not magic, right? We think this is a good change, and it's going to lead to way higher level of concurrency, but there's always a trade-off, and this is the trade-off. You have to think about that. Now, you can use read isolation to go in and, for example, say, I want to read now with repeatable read, which is also more, more concurrent than update log, but it takes the S log for the entirety of the duration. So you can do it like that, and you can read isolation to do that if you want to, but by default, that's not the choice we made. Now, when let's take this example that I've given here, where you have two sessions trying to modify. The problem here will be that session 2 will come later and try to modify, but it has a stale view of the data. Here, the server will detect that situation and throw an exception because you're now trying to overwrite data and you had an old view of the data. So it's a decision we made, and I think that's a reasonable decision. Right. And this is the code for, you can also do it in a single session, which is a little bit more interesting. I do think we have time to discuss this. It is when you go in and on 3 different records, you read data and then you make the data not consistent on another record. So you write to it, but we detect that scenario. However, if you do it through a modifier, we don't actually know all the timestamps of all the data you modified. So there, we cannot detect that you modified. So we just, within the same transaction, so we'll throw an error there. So it's only if you do, yeah, I think I lost some of you, but only if you do delete all in here, you can end up on modifier, you can end up in this scenario. So we can discuss it later if somebody wants to know more about it. We don't think it's going to be a very prominent problem. Good. We have time for read isolation, I think. So let's just quickly go through that. We've talked about it before, but I want to show it off because it's very related to this. It's a way to get around these kind of places where you need to take some consistent logs. Right? So in version 22 and upwards, we introduced this new way to specify how you want to read, with which kind of isolation level you want to read. Because throughout the entirety of it, we have talked about it is per table. It's not per record. It has been per table, and runtime decides it, unless you call log table. Well, in 22, we introduced the ability to go in and say, actually, on this record instance right now, for my next read and the ones after that, on that one, I actually want to override what the table state is. I want to go in and say, I know I need to read with the update log now. Or maybe you want to read less. You want to read with read committed now or uncommitted. You know that that's fine because you have a specific scenario in mind. So that's what it can do. It doesn't influence other record instances like log table do, and it only impacts read. We still don't put any hints on writes. So I talked a little bit about repeatable read, but that is one of the ones you can select. You can go in and say we take a shared log again, and we take it for the entire duration of the transaction. However, you have to be careful with using that one because you can end up blocking writers. And you can also cause deadlocks. So it's good for if you know you're both trying to read, you want more parallelism, and you also want to ensure no one writes to it. But then you can block other writers. And that's like, what do you want, right? So this is one of the kind of patterns we came up with when we designed this. We call it temporary heightening. So it's like, instead of doing log table, which is I think how the code originally did this, or this is kind of a modified version of base code I took. Normally you do log table here. You go in and say log table, find last, okay, everything is good, right? But the problem is that now, if you do this very early in the transaction, normally they do, every other read would be impacted. But now we can go in and say, hey, just this read is impacted, nothing else later, right? So if you're, for example, writing event subscribers that has to do this kind of things, we really recommend you to use this pattern of temporary heightening. And if you think about it, there's also the opposite, right? Temporary lowering, right? Goes both ways. I would say it's better in pretty much all scenarios where you need to do it instead of log table, unless you really need what log table does, but it's very rare we found too many people who really want that. But if you need it, of course do it. So if we go back to the quiz, right? That quiz, I'm not going to say if it logs or not. I'm going to kind of show the difference, right? So there is quite a significant difference here with you can now get read committed on some of these. And if we think about it, it logs, yes, but for a very short duration. And it's also a way more granular log, a more compatible log. So get ready for tri-state logging. I mean, that's the main takeaway. Go and test it. Secondly, getting ready for us was actually quite easy. I was working together with Badu on this, and in the end, there was no significant changes in applications in base app to do this. We spent a bunch of time in the platform making this work. There's a few tests in platform, a few app tests in platform I had to slightly change, but in base app, there was no significant changes. And that's partially because they already began using read isolation. And then consider using read isolation for the places you need it to control precisely how much you want to do it. Good, there's some resources here. If you want to go read more about it, I did a blog post on it where I go a little bit more in depth with the philosophical reason. We have some documentation on MS-Learn about both features, so go read that. I think we have some time left for Q&A if anyone has questions. I'm gonna bribe you a little bit here with the chocolates for whoever asks questions. You can come and get that afterwards. So I hope to get some engagement. Yeah, I think we have this one. I can throw it to you, or Torben can do it.
I have this question. So lock table, as you show, locks the table. So it doesn't matter do you use different variable or whatever, it's still locked. Read isolation level, for example, if we set it to update lock, does it lock the table as well, or the parameter, the record?
Yeah, so great question. So when you say lock the table, the thing is, the platform does not have a big table environment where it takes a monitor lock or something like that. The only thing it does is it changes the table state to say all subsequent reads are done with update lock. That's what lock table does, the only thing it does, right? So read isolation, what it does is instead it says on the record instance, it goes in and says, remember the next time you go to SQL, instead of applying whatever hint the table state says, just apply what you have in memory on the tables, on the record instance level thing. So it does not.
Okay, okay, thanks.
Anyone else? I think that's a question. Oh, thank you, Torben.
Oh. Where was the question?
Oh.
Almost.
So if I want to do a get, usually that won't do a lock immediately. So is there perhaps an idea to make a get with lock, or do I just use read isolation, update lock, do my get, and then go back?
Yeah, so I mean, get behaves exactly the same way when it comes to locking as find. So if you call lock table and then do a get, unless we can serve it by the cache, we will still go to SQL, we'll apply the hint, so we'll apply update lock because you call lock table, and that will take a lock. So get can take a lock. And get gets affected exactly the same way as find does by read isolation.
Well, I only want to log this specific record, not every read that I do afterwards.
Yeah, so then you have to use read isolation, yes, exactly. And that should work perfectly fine. If it doesn't, send me an email, we'll talk about it. Yeah. Anyone else who has a question? Over there, yeah. Oh, sorry.
Read committed.
Yep.
What's the underlying mechanism that you're using? Are you using the read committed snapshot isolation at the server level?
Oh, so that's a very good question. So I tried to avoid talking about that because we didn't really have time to talk about it. But yes, that depends totally on your SQL Server installation. If your installation has read committed snapshot isolation running, then yes, we use it when you do read committed. If it does not, it does not, right? So in SQL Azure, it does use it. But if you're on-prem, I don't know if you are, but for the ones on-prem, depends on how you set it up.
So in Azure then, by using this, you're actually enabling the read committed snapshot isolation, is that correct?
Yes.
Okay, so then my concern here then is that in order for that snapshot isolation to work, it adds 14 bytes to every clustered index, every record. So then if you're working with a very large database, your client database could cross over the 80 gig limit. And are they going to suffer costs then?
No, because SQL Server does guarantee that, well, okay, so cost is one thing, but going over the 8K limit, they do guarantee
yeah, I know
you don't.
functionally that's not a problem,
Yeah.
but there's a cost involved from a client perspective if you cross that 80 gig limit.
Yes.
Okay, so then it could be a surprise to somebody that by enabling this, that they
but
could potentially cross over.
No, so they don't enable it. If
No,
you're on
I know,
SAS right now, it is always on.
Oh, okay.
So I'm sorry, we ran out of time, but maybe we can talk later about that.
Okay.